All right, guys, so we're going to go over lesson one. Um, we're going to discuss limits. So this is a very important part of calculus. This is a concept that we need to understand. This is the basics of it, very foundation of calculus here. So I want to make sure we understand everything that's going on. So if there's something you didn't understand in this PowerPoint, study it, look in the textbook. Um, there's a study plan where you get extra practice, guys. You get all the practice you need, and reach out and get help. So we need to make sure we understand this. So in this lesson, we're going to do a few different things here. We're going to find limits of a function. All right. We're going to determine if they exist. And if they exist, we're going to find them by using two different methods here. We're going to use numerical methods, and then we're going to use graphical methods. So we're going to solve it numerically with the numbers. And then we're going to graph it. We can determine if there is a limit just by looking at it and not actually doing the number or algebraically. So keep that in mind when you go to do your homework, that there's a few different ways that you can actually find your limit. We're going to actually go through, to begin with, we're going to go the long way. Okay, we're going to do it numerically, but that's because I need you guys to understand what this limit is. And then because we can do it numerically, we should be able to understand it better. When you see it graphically, you should understand what's going on here. So your definition: as x approaches a, the limit of x, the limit of f of x is L. And the way it's written is the limit as x approaches a of f of x is equal to L. And before I go any further, I would advise you guys to um, print out your PowerPoint and have it ready, so you can fill this in and you can follow me here so you understand what's going on. Okay, so this is the very definition of the limit. All right, so let's go to the next page, and we're kind of determine, what this is and what it means, and I'll go into more detail, but that's the definition of a limit. So to find the limit, two things must be true. It says as x approaches a, the limit of f of x is L if the limit from the left, and I'm going to highlight this, if the limit from the left exists and the limit from the right exists, and both of the limits are L. So what this is saying is that I need to find the limit as I approach my value from the right. There's the right, that little positive sign. That's positive numbers. The way I think of it, my positive numbers are on the right side of my axis or my number line. So when you see A with a little small plus sign up there, that means I'm approaching A from the positive side or from the right side. And then as I approach my number from the left, that is A with a little negative up there. That's not an exponent. That's just a symbol saying as I approach from the left. What has to happen is those two limits must be the same. In other words, those two values, when I'm substituting in, those two values must be the same. If those two values are the same, then we say the limit exists and the limit is equal to whatever value it is that we found. Okay, so that's a lot, and I know it sounds kind of confusing, but we're going to go through a few examples and see how we feel about this. Okay. Um, this quick check. Well, why not? Okay, we can kind of go through this. So this is a quick check that the PowerPoints have in there to kind of get us introduced to this concept and kind of break it down a little bit. So it's giving us this function f of x, and part A is asking us to find f of 3. So we know this. We went over chapter R. We have reviewed this. I know that if I want to find f of 3, then what I do is I substitute 3 into that function. That would give me 3 squared minus 9 over 3 minus 3. Then what I have here is that 9 minus 9 over 3 minus 3. And if you notice on the bottom, I would get a 0. And we've already discussed this, that you cannot let that happen. you cannot divide by 0 because I end up with 0 in the bottom. What I can say is that that value does not exist. So I don't have a value for that particular number. When x is 3, the function does not exist. But now we're going to take it a little bit further. We're going to say, well, what is the limit of that function as we approach 3? In other words, the way I kind of think about that is, if there was to be a value at 3, what would it be? That's the way I look at it. Okay, that's the way I read it. So if there was a value at 3, what would it be? So what value am I approaching? There's not a value there. I don't have a number there. But what value is that graph approaching? It may be approaching a value, it may not. Okay, so keep that in mind. We're going to see if I do have a limit. I want to see if I do approach a particular number. Okay. So let me skip to where my work is. So here's what we're going to do. I have a table in your PowerPoints, and I broke it up. I have two little tables here. We're going to approach 3. This is where we approach from the left. We're going to approach 3 from the left. I have that little -3 there. And then down here in this table, we are going to approach from the right. And how do I know that? Those little symbols. That little plus there tells me I'm going to approach 3 from the right. That minus tells me I'm going to approach the left. Guys, this PowerPoint already kind of peaked my values here. But when I'm approaching from the left, what I do in my mind, let me come over to the left over here. Okay, you got to picture a number line. 3 is right here on your number line. Okay, so you've got to figure out what numbers are to the left and to the right. Well, to the left of 3, what values do I have? I have 2, 1, 0. I can really go as far to the left as I want. That's not going to help me. What you want to do is you want to start close to 3, close but on the left, and you want to get closer and closer and closer to 3, as close as you can, okay, without actually ever reaching 3. So in other words, you want to find values that's within this little area here, okay, to substitute into that table. So what they chose is they started at 2. They gave me a nice whole number, and they divided that by 2, and which gave me the 2.5, okay, the distance there. And then they chose the 2.9, which is closer to 3, and then 2.99 and 2.999. So they took all of those numbers and they substitute those into the function here. If I remember correctly, I can't see it on this screen, but the function was f of x is equal to x squared minus 9 over x minus 3. So what I'm doing for my table is I'm substituting each one of those values in. So 2 squared minus 9 all over 2 minus 3. If I simplify that, that's just going to give me 5. So I'm going to put 5 in here. We're going to do the same thing with 2.5. That's going to give me my 2.5 squared minus 9 all over 2.5 minus 3. And that gives me my 5.5. Do the same thing for, I have 2.9. That's going to give me my 2.9 squared minus 9 all over 2.9 minus 3. And when I simplify that, that's going to give me my 5.9. Let's come over. If I take my 2.99 and I substitute that in, And guys, I know I'm writing kind of fast. That's because I have class in just a minute. But if I'm going too fast, don't forget this is a video. You can pause it, okay? Slow down. Write this in your notes and resume the video. All I'm doing here is substitution. If I take that 2.99 and substitute it into that function, that gives me 5.99. Then I'm going to do the same thing, 2.999. If you guys notice, I started at 2, then I had 2.5, 2.9. My question was, what is the limit as I approach 3? I'm approaching 3 from the left. I'm choosing values that are right below 3, but I want them to be very close to 3. So that's why we have that 2.999. It is very close to 3, but it is not the same thing as 3. So we're going to take that 2.999, substitute that into that equation. And when I simplify that, that gives me 5.999. Now I'm going to come back over. What happens here? Well, my value starts at 5, right? Let's highlight this in blue. Start at 5, then I have 5.5, 5.9, 5.99, 5.999. What's happening as I approach 3 from the left, the value of that function is getting closer to 6. I am approaching 6. Okay. So I'm going to take time here. Well, let me make sure I explain what I have in this second table. At the bottom, I'm going to see what the limit is as I approach 3 from the right. Now, if you remember, that definition says you only have a limit when the limit as you from the left and the limit from the right. If they are the same, then you have a limit. Okay, so I substituted values from the left. I now need to substitute values from the right. And I'm going to give you guys, you could pause the video, substitute these values into that same function. And let's see what you get. Okay, I'm going to assume that you guys paused and actually substituted into the equation. If you did, what you should have gotten was 7, 6.5, 6.1, 6.01, and 6.001. What did you notice? Well, as give me just a minute here. So if you notice, what happened here is as I approach 3 from the right, my values, I'm going to highlight this in yellow. My value started at 7. As I got closer to 3, those values are getting closer and closer to 6. So what I want to add here is that as I approach 3 from the right, the limit is 6. But down here, I want to highlight this in blue. Since both of the limits, since the left hand and the right hand limits agree by that theorem that we talked about earlier, we can now say that the limit as x approaches 3 of f of x is equal to 6. So although I do not have a value at 3, I can assume, or I now know, that the limit as x approaches 3 is 6. Okay, so the value that we're approaching, although we don't ever actually reach it. Okay. I hope this makes some sense to us. So there's a few examples here. So let's go through one of these. We can do A, okay? So I'm going to kind of cheat and let you know that the limit does not exist for this at that point. So you guys can kind of see what it looks like when the limit does not exist. So let's jump into part A. I need to write my equation down to the left. So what we had was h of x is equal to that 2x plus 2 for when x is less than 1. And then we have that 2x minus 4 for when x is greater than or equal to 1. Okay, we want to find the limit as x approaches 1 from the left. I highlighted that in yellow. So if you imagine your number line, okay, and we're approaching 1, well, to the left of 1, I have 0. So they're starting at 0, and they're going to gradually get closer to 1. So what they're doing is they are taking values and they're substituting it into the function. Okay, now you got to keep in mind, this is what we call a piecewise function. Now, when you go to substitute into this function, you've got to make sure you substitute into the correct piece. Okay, so if I'm substituting 0 or anything less than 1 into this equation here, this function, I've got to use the 2x plus 2. So for all of these, from 0 to 0.999, I'm going to substitute into that 2x plus 2. So then I have 2 times 0 plus 2, which gives me 0. I have 2 times 0.5 plus 2, which gives me 3. Then I have that 2 times 0.8 plus 2. That's going to give me 3.6. And we're going to do that for each one of these values. And you can pause if you want to. I'm not going to write all of these out, but all I do is I substitute each one of these into the function 2x plus 2. And the values that you get is 3.8, 3.98, 3.998. We have a pattern. Okay, I started at 0, but the closer I got to 1, it appears that the limit, as I approached 1 from the left of that function of h of x, is equal to 4. I started at 0, but I approached 4. I'm getting closer to 4. Okay. Well, that's just from the left. Well, let's see what happens as I approach from the right. So I need to write my function up here so it makes sense to me. My function again was that h of x was equal to that 2x plus 2 for when x is less than 1. Then I have that 2x minus 4 for when x is greater than or equal to 1. But now this time, imagine your number line, okay? The value we're concerned most with here is 1, but I'm going to approach from the right. So what number is directly to the right of number 1? Well, number 2. So we're starting at 2, but then we're going to inch closer to that value that we're most concerned about, that 1. So we're starting at 2, then 1.8, 1.1, 1.01. Now I want to make sure that you guys understand that this can be anything. They can be any values that you choose, but the goal here is to make sure